Welcome everyone, and welcome to those watching on our live stream on YouTube. We love to encourage you to use the chat tonight, and if you could, just let us know where you are watching from. We will get started in just a few minutes. I see a few people still joining, so I just want to welcome all of you that just joined. Thank you for being here tonight. We're so excited to have you, and welcome to those watching on our live stream on YouTube. We'd love to encourage you to use our chat tonight to comment or ask any questions, and please let us know if you're just coming in where you are coming in from. We'll get started in just another minute here. Okay, so it's about 6:04, so I think we will go ahead and get started. Welcome everyone, welcome to those watching our live stream on YouTube. Again, we'd like to encourage you to use the chat window for any comments or questions, and also let us know your location if you haven't already. My name is Katie Flynn with the Aerospace Corporation. I'll be your host this evening. Thank you so much for joining Audience with Aerospace Mars Landing on this momentous day to kick off Engineers Week 2021. Today is all about planet Mars. So earlier today, NASA landed 2 objects on our neighbor planet Mars, none of which could be done without engineers. You can observe Mars with the naked eye tonight in the night sky. The planet is high, and if you look outside, you can see that the moon is right next to Mars tonight, and we may be able to see that through our telescope in just a little bit. Just recently, Ed Swallow, our senior vice president, read a book for World Read Aloud Day called Seeing Red, a book about Mars, and we thought it was perfect for telling you some facts about the planet before we view it. So this is just over about 2-minute video that we will show right now.
Mars is actually a small planet, but it can be seen from Earth with the naked eye. In ancient times, its reddish color made people think of blood. As a result, they named the planet after the Roman god of war. Today, we know that that color comes from iron, a metal found in the planet's soil. So a fun fact, of our solar system's 8 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, Mars is the 4th planet from the sun. It is also our second closest neighbor. Venus is actually a little bit closer. It's small and cold. Mars is much smaller than Earth. Its diameter is about a half of Earth's diameter. Only the planet Mercury is smaller. Because Mars is farther from the sun than Earth is, the planet is much colder. The average temperature at the surface is around minus 80 degrees Fahrenheit, which is minus 62 degrees Celsius. The atmosphere, or layer of gases around Mars, is very thin. It doesn't hold much heat. So as soon as you go from day to night, the temperature changes dramatically. So the fun fact is the average temperature at Mars' surface is about the same as the average temperature at Earth's South Pole. So spinning and circling. A day on Mars is only a little longer than a day on Earth. The planet takes 24 hours and 37 minutes to spin on its axis one time. A Martian year, however, is almost twice as long as an Earth year. Mars takes 687 Earth days to orbit or circle around the sun. Earth takes just 365 days.
So some fun facts that we just learned about Mars. It is the 4th planet in our solar system. The only planet smaller than Mars in our solar system is Mercury, which is the 1st planet. And the reddish color comes from iron in Mars's soil. So we are here today because Perseverance rover and Ingenuity helicopter landed on Mars earlier today in Jezero Crater. Jezero Crater could have been the home to life on the red planet and may help us learn more about surviving on Mars. The mission consists of bringing samples back to the area to Earth to study, from the area to Earth to study. A fun question to think about is, could microbial life such as tardigrades survive on Mars? Perseverance rover has a microphone and descent camera, which hopefully captured some of the sound of the arrival and landing on the planet, none of which could be done without engineers. Here's a look at Mars' surface, and we have a fun poll for you to guess where you think Jezero Crater is located on this map, the place where we landed. So if we can pull the poll up. And please vote for where you think Jezero Crater is. That's where the rover and helicopter are right now. All right, looks like 47% C, 5% A, 32% D, and 16% E. And we'll stop sharing those. So the answer is actually D. So that's actually quite a large area that's circled right there. Jezero Crater is much smaller if you zoom in into that area. So speaking of Jezero Crater, earlier today you may have seen the NASA feed of the landing. And when Perseverance landed, its first image was captured of Jezero Crater and sent back to us. And this is Jezero Crater. So that's very exciting that we now have a picture of it and all of the things that Perseverance will be doing. Now we'd like to give you a few minutes to go to our website to print out an activity for all ages about Mars. These are coloring images from NASA. So if we can we'll put the link in the chat and just give you a few minutes to get there. It should be right under the first event, the Mars event, where you find the link. Please let us know if you have any questions or comments in the chat. All right, so these are some of the activities that we love sharing with you. This one is for all ages. And then we also have more activities. If you follow us on our social media platforms that are listed there, we'll be posting every Saturday a STEM event or activity for you to do. This one here is for grades 3 to 8. We want you to be an engineer that launches and lands a rover, just like on Mars. Discover E has a wonderful engineering activities. So you can go to their website as well throughout Engineers Week and find so many more activities. This one specifically is for you to launch and land your own rover, just like the engineers did for Perseverance and Ingenuity. So without further ado, I would like to introduce our astronomer that will be showing us planet Mars through AeroTel tonight, Amanda Bayless. Dr. Bayless is a research scientist at the Aerospace Corporation in the Remote Sensing Department. She received her PhD from the University of Texas in Austin, her master's from San Diego State University, and BS from Michigan State University. She's been interested in high energy physics from the beginning, working for CERN, building part of the LHC, which is the Large Hadron Collider, the Fermilab, while at MSU, and her background includes studies in neutron stars, black holes, binary systems, and now supernovae research. She also worked on the Lucy mission, which launches October 2021 to explore asteroids around Jupiter. So I will stop sharing and let Amanda take over.
Hi. Yeah, good evening, everyone. Thanks for that, Katie. I'm getting some feedback. So there you go. So yeah, thank you. So the picture of me in the middle there, that was not next to Perseverance. That was next to Curiosity, the rover that went before this one several years ago. That was the engineering unit. That was not the one that actually flew. That is one that stayed behind. So if something bad happened to the one up on Mars, they could run the same software and run the same tests on that unit and try and diagnose what happened. And I'm also a knitter. So here is my Pluto. And I also don't want to give Mars all the love. Today is also Pluto Day. Pluto was discovered 91 years ago today, February 18th, 1930. So a little love for Pluto. And if you ask me it's a planet or not, officially no, but in my heart, yes. All right. So yeah, so I'm going to show you our telescope that's located on the campus of Aerospace in just southern part of Los Angeles. And I just want to also note that this is a fully robotic telescope. I am not in Los Angeles. I'm not even in California. I'm actually in San Antonio, Texas right now. It's still snowing, I think. But we can control this telescope completely robotically. So even though it's snowing here, I can actually use this telescope and completely control it. So I'm going to show you our dome cameras right now. That's actually sharing. There we go. So here's our telescope. You can see we have 3 cameras that are internal to the dome. One rides along with the telescope itself. And then we have an external camera looking at the dome from the outside. And this is a 1-meter telescope. And when we say a 1-meter telescope, that means the primary mirror is 1 meter in diameter. And I can actually remotely move the telescope so you can look down the barrel of the telescope here. Move it a little bit more. And so there you can see the mirror at the base of the telescope right there is 1 meter in diameter. And so that's our primary telescope that we use to do our observations. We have a camera that can sit out the front or sit off the back and do our science. And then we also have a 12-inch camera or 12-inch telescope that rides along with the 1 meter, and that's riding along the side. You can see it kind of at the top here in that view, but in the telescope that the camera that rides along with the telescope, this white tube off to the side is our 12-inch. So what I'm going to do is actually show you how we open the telescope and go through what I would go through if I was going to do a night of observing. So the first thing I'm going to do is tell the telescope. So we have a dome that has to align with the telescope. And so I'm going to connect the dome to the telescope. And of course, I'm going to get an error here. It doesn't always work. This is real science. Sometimes our software doesn't always work. And then we just restart our software. Save the telescope. All right, if you give me 1 second, I will try to clear this error.
We have a few questions while we're waiting.
Sure.
Jane asks, has the helicopter flown yet?
It has not flown yet. I don't know when the actual plan is to fly it. Right now, since it just landed, they're going to be doing a lot of system checks, calibrations, make sure everything is ready to go. So it's going to be a little while. They want to make sure all the rovers cameras are working. So that takes a few days, if not a few weeks, to get all of that working. So I'm sure there is a schedule. I don't actually know what it is off the top of my head here. Oh, there we go. I think it's working. Why are you not? There it goes. And hopefully, there's the dome moving. Hey, we got it fixed. All right. So there's if you're looking down the barrel of the telescope here, so that it's going to oscillate a little bit before it settles. So there's the opening in the side of the dome that I will open in just a moment. And I'm actually going to turn off the lights because we don't want light going off into the sky. And we're going to open the dome. So you'll start seeing the slit open. And this takes a little while, so if there's any other questions, I'm happy to answer questions at any time. Just feel free to ask away.
We do have one. Do we have plans to put people on Mars?
So there has been a lot of talk about that. Of course, that's an endeavor that is very expensive, number one, and also very dangerous. We don't have really the technology to put people on the moon right now. We sort of lost that ability after the Apollo era. Um, and so that's kind of the first step is we need to put people on the moon to make sure we understand how to do that. Um, there are rockets being tested right now that do have that ability. So there are definitely plans to do that. And Mars then would be the next step. Of course, Mars is very different because if you go to the moon, it takes about 2 weeks or so with all the orbits, the trajectory changes to get there, and about another 2 weeks to get back. So you're looking at maybe about a month, maybe a month and a half mission to go to the moon and come back. If you're going to Mars, it takes 8 months at best to just get to Mars. And then you're going to want to spend a time on Mars because you took a while to get there. And then it takes 8 months to come back. So you're looking at least a 2-year mission of sending people out into space. And that has its own dangers as well. With radiation, the space is actually a very harsh environment. There's a lot of radiation from the sun. When astronauts are on the International Space Station, for example, if there's a big solar flare, they actually have a panic room on the International Space Station that is very well shielded, so they can go into there and not get irradiated by the sun. And you don't want to get too much radiation because then you can get cancer and other bad things. So they go in there until the event has passed. If you're out in space traveling for 2 years, that's something you have to consider. So we have to keep our astronauts safe. So it's a very challenging problem to try and do that, but there are plans to hopefully do that one day soon. Okay, I think we're open. Yes, we are fully opened. Hooray. And I am now going to move the telescope over to Mars. There we go. Give me 1 second. And slew. And there we go. There goes the telescope off to go point at Mars. And hopefully the dome, yep, it's trying to follow. The dome will follow shortly behind and they will stay aligned. So I don't have to tell the dome to go point at Mars. It knows where the telescope is, usually, and then can point at it. Oh, and there it is. You can see Mars out the slit. Oh, looks like we might be fighting some clouds, but we'll see what we get. The dome's going to try and dance around. There's the moon, that bright, really bright thing right there. You can see in the camera is the moon. So the moon's very close. There it goes. The dome finally settled. It doesn't always like pointing straight up, and it has to kind of figure out where it is when it does that. It takes a minute or two to figure itself out, but it usually does that okay. And so if I stop sharing this screen and hopefully go over to our camera, yes, we'll be able to see Mars in the camera. Now, Mars isn't, I mean, it's still kind of a dot, so you're not going to see the lovely pictures that were shown in the slide. Those are images that are from Hubble. This is a tiny telescope in the middle of downtown LA. We are not Hubble, so you're not going to get those really spectacular images of the surface of Mars from our telescope. But there it is. So here it is. That bright thing right there is in fact Mars. And I have it set so it's taking an image of Mars every 10 milliseconds. So it's going to keep refreshing. So if it suddenly fades, that means a cloud came over. So that's real astronomy. We have to fight clouds. But I also want to highlight, so if you see this little thing called a filter wheel control. So what we do when we do our science observations is we will put different filters in the light path of what we're looking at. So what a filter does, it blocks out certain wavelengths of light and only lets other wavelengths through. So we want to look at it in different colors. If you do a lot of photography, you might be familiar with this, where you have like an R, a G, and a B. And if you combine RGB, you get a full color image. So that R and a G and a B is actually a filter. The R is red, the G is green, and the B is blue. So we have very similar filters on our telescope, but we actually have a bonus one in an infrared filter. So there is certain light that our eyes see. We see a rainbow spectrum, right? Roy G. Biv. But there is light outside of that visible spectrum that our eyes can't see, like UV, ultraviolet light, for example, that gives you a sunburn. On the other side, next to the red end, that's infrared light. And so we can't see infrared light, but our telescope can. And that's what we're looking at right now. So this eye filter actually means infrared. And so Mars looks pretty bright. Mars is very red, as we know. And so when you look at it in very red filters, it's going to seem very, very bright. And so there's Mars. You can see it kind of, we're fighting some upper level clouds, I think. You can see it kind of dancing around, twinkling a little bit, even though it's not a star. You get that from some clouds. We call it seeing. Seeing is different than clouds. And it's just kind of, what makes the stars twinkle in a telescope can sometimes make planets twinkle too. So if I go through these different filters, so that's the I. If I go to the R, or the red filter, it'll get possibly a little fainter, not a whole lot different. You can see now there's kind of that twinkling is down a little bit because it's not quite as bright. But if I go to V, now V means visible. It's very similar to a green. So it's kind of the middle wavelength of what our eyes can see. So this is essentially, if you looked at Mars, this is the same as what your eyes would see. You can see it's getting a little bit fainter there. As we're moving to bluer colors, we're blocking more of the red light. And so it's going to look fainter since Mars is so red. And then if we go all the way over to blue, you can see there's very little light coming through at all. Mars does not have a lot of blue light coming from it. Of course, Mars, like all planets, reflects light from the sun. So our sun produces all wavelengths of light. It produces all colors, even the ones we can't see, including ultraviolet. You get a sunburn. And X-ray, infrared, all of the wavelengths of light, all the colors we can see and can't see. And so all of those are also reflected by the planets back out into space. But Mars also has some intrinsic color. It's more likely to reflect that red light than the blue light, which makes it look red. That red is from iron oxide. It's actually rust. So the same rust that you get on your car, that orange color is what makes Mars the color that it is. So I'll go back to the infrared here. So if there's any questions about Mars, so before we go to the moon, I can pause here to take some questions.
Yeah, so we have a few questions. What type of telescope is it, and what is the name of the telescope?
So the telescope, both of the telescopes are called Cassegrain telescopes, and so they are Cassegrain telescopes, but they're not always used as such. And let me explain. So a Cassegrain telescope, a classic Cassegrain, so it has mirrors, and light comes into a primary mirror, reflects off that big primary mirror, goes up to a secondary mirror, and then reflects back through a hole. If I go back, just you can't see it because it's dark. But if you saw, if you remember that 1 meter mirror, there was actually a hole in the middle of it, and light goes through that hole, and we can put a camera on the back of the telescope, and the light would then go to that camera. We don't usually use the 1 meter as a Cassegrain. We use it what's called a prime focus telescope. And that means light hits that primary mirror, but then we actually have a camera set up at the secondary, and the light just goes right to our camera. It doesn't do this kind of double bounce into a camera off the back end. Sometimes we have large instruments that we can't fit on the end of the telescope, that has to ride along with the telescope, and then we will stick them off the back end, maybe even on a table, and we can have fiber optics coming from the telescope feeding a larger instrument. We do a lot of prototyping with this telescope. The telescope itself is called AeroTel, for Aerospace Telescope. It's the entire observatory. So we have the two telescopes together are AeroTel. And so we don't have individual names for the 1 meter or the 12-inch. And we have a 20-inch in development, so we're working on building that now. So that's going to be fun. We'll have 3. But we do a lot of prototyping with cameras, new cameras that we're working on that we might be building at Aerospace. And we go to different facilities. So there's different observatories. There's the Lick Observatory near San Jose, Mount Lemmon Observatory in Tucson. We go to an observatory in Maui sometimes. I have yet to do that. I'm kind of waiting and hoping that happens soon, but because Maui. But these are much larger telescopes in much darker areas on mountains, real quote unquote, observing telescopes. So, but before we take a new camera to one of these telescopes that involves travel and it's expensive to get there, we want to make sure our camera works. So we will test it on our 1 meter here in practically downtown LA, where maybe it's not great for science because it's downtown LA, but to test a camera and make sure it works, it's perfect for that.
So we have some more questions. This one is, how does Mars's gravity make it harder to work for engineer machines in different gravity?
Sure. So Mars, it's about 1/4, I believe, the gravity of Earth. So it's not quite as bad as the moon, but it does have a less gravity. So you would be bouncing around like the Apollo astronauts did on the moon. So you have to take that into account. And it's definitely hard to land on Mars because it has a high enough gravitational pull that you have to use a parachute, and it has an atmosphere that you have to deal with. So when the Apollo astronauts landed on the moon, they had little rockets on their Eagle lander, and they could just use that to gradually descend down to the moon. They didn't need an elaborate system of parachutes and a sky crane and rockets and everything else that Perseverance needed, because the gravity's higher. So little tiny rockets are not going to slow you down enough to land on the surface. Gravity is going to pull you down. So it's definitely a harder problem to land on Mars, to have a very controlled descent. So it's quite an engineering feat that both Curiosity and Perseverance were able to land with these parachutes and sky cranes, and it's amazing. I'm still kind of amazed by it personally.
So we have more some weather-related questions. Because of the thin atmosphere, how does that affect the overall performance of the parachute used to slow down the rover?
Yeah, so that was very, they had to develop a brand new type of supersonic parachute. It had never been done before. It was done first for Curiosity, and they used it again for Perseverance. But it was tough because we can't replicate Mars's environment. So when they used the parachute for Curiosity, it had never been field tested before. You can't field test that. It just had to work in our computer models. I say ours, like I had something to do with it, but it had to work in their computer models. And you launch it and you hope it works. You do as much testing as you can, but we can't replicate that atmosphere very well. So it was a challenge, and it's It was a brand new parachute for Curiosity, and it worked for Curiosity and it worked for Perseverance.
Amazing. So what is the best weather for a rocket launch or a helicopter to take off?
So for rocket launches, would be great if it's sunny. For launching from Earth, that would be great. For the helicopters, I'm going to assume it means a helicopter on Mars. So as long as there's not a big dust storm that kicks up, and Mars has some terrible dust storms, orders of magnitude worse than anything on Earth. I think it's fine as long as it's the things are normally things are fairly calm on Mars, and so as long as something like that doesn't happen, I think the helicopter will be just fine.
And just a couple more, or they keep coming. Do you believe that we will one day be able to see Mars as clear as Hubble from Earth if we don't already? How long do you think this will take for us to develop?
So I don't know that. So there are some telescopes in development now from the ground. The largest telescope now is Keck class telescopes, and they're 10 meters. So our is 1 meter diameter. Their mirror is 10 meters in diameter. And there's several of this class around, so 8 meters to 10 meters. And they can see some very nice surface features now. It's not quite as clear as Hubble because on Earth, we will always be fighting through our own atmosphere. And I mentioned before the clouds and the seeing. If you have a star twinkling, that means you don't have a sharp image in your camera. That image is dancing around. And the worse you're seeing, the more that image dances around. So if we had really bad seeing, you would actually see Mars dancing around much more than it is right now. You can see it kind of shifting around a little bit now. So that makes it very hard to get a hyper clear image. But with Hubble's in space and it doesn't have to worry about the atmosphere. So there are things that we can do to correct for the atmosphere, but we're always going to be hampered by it. There are some telescopes in production now that are 30 meters, so 3 times bigger than the 10 meter and 30 times bigger than AeroTel. I'm not sure off the top of my head how great of a resolution they would be to see Mars. It would certainly be, the amount of light collection goes as the square, so it would get 9 times as much light as the 10 meters. So 3 squared, 9. So it will definitely be better, but just like the 10 meter classes, they're always going to be fighting the atmosphere. So we'll see.
We just have a couple more. This one, would it even be possible to land on Mars because of such high gravity than your body is used to?
So Mars has less gravity, not more. It's about 1/4 as much. So it has more gravity than the moon, but less than Earth. So if you weighed 100 pounds on Earth, you would weigh 25 pounds or so on Mars. The moon is about 1/6, I believe. You can correct me on those numbers. I'm kind of pulling them out of the top of my head, so don't quote me if I'm not quite right on those. So I mean, we landed people on the moon just fine, and there's more gravity on Mars than the moon, and certainly, but there's less than the Earth. So people would be just fine on Mars. They'd be bouncing around, not as much as they did on the moon, but certainly there would be that kind of effect where you would feel like you're, hopping around. Other planets would have issues if we got near Jupiter. We can't land on Jupiter, obviously, because it's it's a gas giant. There's not really a surface there, so you can't land on it. But the gravity there is significantly higher, and it would be quite crushing. Same with Saturn. We have flown spacecraft into Jupiter and Saturn, And they survived for a while through the atmosphere, but eventually the gravity and radiation also crushed them. So they did not survive too long.
Someone has a question about how people would feel that they can't hug their loved ones when they are in space.
Oh, yeah. So there's been some talk of at some point having maybe not the first missions to Mars, because it is a 2-year mission, but maybe actually having whole families go at some point. So you could the astronauts could take their families with them, especially if it's more than a 2-year mission. If we're talking 5, 10, actually setting up bases on Mars, now this is a very big endeavor. So yeah, I mean, it would definitely be tough to be away from your family that long. But there is communication. Mark Kelly is an astronaut that was on the International Space Station for an entire year. And he was able to talk to his family back home through phone. There is a time delay. So you would say something and then you wait a while. And, if you think your internet lags now, try waiting 10 minutes to get a reply back from someone. But yeah, so it would definitely be tough. I don't disagree with that. But maybe we'll have whole colonies and families will go together to Mars.
Would we get better pictures of Mars if we had a telescope on the moon?
So yes, that is probably true. Just because there's no atmosphere on the moon. There are talks now of actually building telescopes on the moon, particularly on the far side of the moon, and that kind of actually segues nice. So would you like me to go to the moon now, since we're kind of segueing to that nicely? So let me go over to the moon while I talk about the moon. Give me 1 second. I need to click a button. And we're going to slew over to the moon. Goodbye, Mars. And there's the moon. Big old moon. So we're still in the infrared band here. So let me go over to the V band, the visible band. And it'll get a little bit brighter, kind of more of an image of what we're seeing. And there's that seeing again. You can see the moon actually changing shape. It's getting squishy and elongated and changing shape. So we're fighting some turbulent air in LA right now. But there's the moon. So yeah, so there is talk of putting telescopes on the moon, particularly on the far side of the moon. So the moon face that we're seeing now always faces the Earth. We always see the same face of the moon. And as the moon orbits the Earth, it rotates to match us. So you can imagine this is the Earth and this is the moon. And so as it rotates, it always turns to face the Earth. So we always see the same face of the moon. We never see the far side of the moon, which is different than the dark side of the moon. The far side of the moon we never see. It actually has a lot of craters. Looks very different than the near side that we are seeing. But the nice thing about the far side is that since it never sees the Earth, the sky is pretty dark most of the time, unless the sun's in the way, of course. But just as the moon is very bright in our night sky, and actually if you're doing deep sky observing as an astronomer, you try and observe on nights where the moon isn't there, because really bright moon next to very faint things makes the faint things hard to see. So if you have a telescope on the far side of the moon that doesn't see the really bright Earth in the sky, it makes observing dark things easier to see. So not just for observing Mars, but actually primarily observing more deep sky objects. And there's several proposed telescope designs to do that, built both with people, and some are actually built completely robotic autonomously with rovers. So they're kind of interesting designs and engineering feats.
And we'd also just like to mention that your niece is also tuned in, Amanda.
Hi, Meg. Hi, Mallory.
So what is the best filter to use to see the moon?
So the moon is very reflective of sunlight and even light from the Earth. So if you're in a fairly dark place and you're near new moon or where you just see a crescent, you can actually get what's called earth shine. So it's light that the sun is hitting the Earth, and then the Earth is reflecting that light back to the moon, and then the moon is reflecting that light back to us. So it's very faint, but you can actually see it. And as Earth is getting worse with light pollution, so turn your lights out, don't use blue light. It's actually getting, the Earth shine is getting brighter. We've actually seen just pure light coming from the Earth reflecting off the moon now from our own light pollution. So because of that, the light that we see with our eyes is usually the best to see with the moon, which is why I went to this V filter, which is what our eyes see. With this telescope, it's not so much of a, you can't really tell much of a difference between the V band or the infrared band or blue band. The moon is pretty white to what we're looking at. It's pretty uniformly reflective in these wavelengths. So it's not like Mars, which is very distinct red. So you don't get quite the difference with the moon.
Do we have any more questions? You guys can type them in the chat. If so, those are all of the ones so far, Amanda.
Okay, I can just highlight a couple of things. Hopefully you can see my cursor. So this big crater here, it's not actually a crater, this dark area. This is called the Sea of Tranquility, which is where Apollo 11 and many other the Apollo missions landed, was in this area. So we call it the Sea of Tranquility. It's called a Maria, but it's not a sea. So unlike the crater where Perseverance landed, which used to actually be a lake, there was real water there at one point in time, billions of years ago, where Perseverance landed. There's never been water on the moon. So we call these seas because they're big, dark areas that resembled seas to early astronomers. And there was a thought, perhaps, that there was water on the moon back hundreds of years ago when we first started looking at the moon. But as we know now, it's all rock, and the moon never had water. But the name stuck, so astronomers are good at that. We name things, and then the name sticks, whether it's a good name or not. So this is the Sea of Tranquility, where several of the Apollo missions landed. There's several other seas, quote unquote seas, around it as well. They are lava flows. So there was early on in the moon's lifetime some significant lava flows as the moon was still cooling down after its formation. And so these kind of areas are kind of older lava flows that covered up some of the early craters. So you see these kind of highland areas where a bunch of craters happened, but then the lava flows came over and smoothed that area out, and you get this dark area where the lava was. And then the moon cooled off. And of course, all of this happened several billions of years ago. So that's how we get these dark areas on the moon, but no water, even though they're called seas.
We have a good question here. Will we start a base on the moon, and could people live there and then travel to other planets?
So I do have to put I should put an asterisk on that no water. There is actually water on the moon, but it's not a sea like we're seeing as a big body of water like a lake. There is water trapped in the rock. There is some ice at the north and south pole of the moon. It turns out there's more water than we originally thought there was. So we kind of went from this period of early astronomy, thousands of years ago, of saying, oh, there's these big lakes and seas, to, oh, nope, the moon's all rock, completely bone dry. There's no water there at all. To a decade or so ago with the Lunar Reconnaissance Orbiter, and sending missions, space missions to the moon. So we have telescopes and we have spacecraft in orbit around the moon that are studying the moon. And turns out they found water at the poles, and more than we thought there was going to be. So there's a potential of maybe harvesting that water. And of course, that's the key to really getting a base on the moon, is transporting materials that you need to the moon is very expensive and hard to do. If there's a way to get what you need from the moon, like water already there, now that becomes a lot easier. So I think it's possible. It's going to take a lot of work and a lot of engineering. So those of you that are in school now, maybe your generation will figure out how to do that and make that a real reality. So that's your challenge. Put bases on the moon.
Yeah. What about any plans for space tourism?
So that may happen sooner rather than later. Certainly companies like Virgin Galactic, SpaceX, they already have passengers paid for and booked. But these are missions that would go up into outer space, just orbit the Earth and then come back. These are not missions that are capable of going to the moon or beyond yet. But I'm sure if a company wants to do that, they could probably figure it out. And I don't begrudge privatizing space at all. I think NASA and private industry need to work hand in hand. It's not a competition between private industry and NASA. They quite often work together. And I think that's how real advancement is going to happen, is having this collaboration and cooperation.
So those are all the questions in the chat. Thus far, if you have any questions, please type them in for Amanda. We just have a little bit of time left if you have any.
So, yeah, see the moon's really dancing around there. Thankfully, it's not cloudy, but the air is pretty turbulent. So we're getting that. Even the moon is twinkling. That's how bad it is. Not just stars twinkling, but the moon is now twinkling. And you can see that the moon is near first quarter. So we're seeing half illuminated. So that's the light half. And then we have a dark half. So the dark side of the moon, if you will, is this dark side, which I said is different than the far side. So the dark side is the side of the moon that is not illuminated by the sun. So as we're seeing the moon now here at first quarter, we're seeing half that's half of the light side and half of the dark side. Whereas we always see the near side and we never see the far side. Only the Apollo astronauts have seen the far side of the moon in person. So, but maybe one day more people will. So there is a dark side of the moon, but it's not the far side of the moon for any Pink Floyd fans.
Well, thank you so much, Amanda, for showing us Mars and the moon. If there are any further questions that you guys would like to type in the chat, please do so. We have about 5 minutes. Is there anything else about the moon or Mars that you would like to say, Amanda?
I think I've talked myself out. But if there's any questions besides, about any astronomy, I'm happy to answer those too. It doesn't have to be necessarily about the moon or Mars either. So
Yeah.
I will go on forever about black holes. So
we had a question about asteroids, Amanda, and if
Sure.
asteroids hit Mars and the moon as well.
Yes. So all of these craters you're seeing on the moon were caused by meteors. So there's a difference between an asteroid and a meteor, and it's a matter of size. So an asteroid is a really, really big meteor. There's not many of those in the solar system, thankfully. So usually it's meteors that hit us. So every time you see a shooting star, that is a small meteor going through our atmosphere. And so yes, they do hit the moon. Every single crater that you see here was a meteor of some kind that hit the moon. They do hit Mars. There are definitely craters on Mars. Because the moon doesn't have an atmosphere, there's nothing to slow down those meteors and have them burn up. So you don't get a shooting star on the moon. It just hits the surface of the moon. Here on Earth, they will burn up in the atmosphere unless they're really, really big, and then they will survive to the ground. On Mars, it's kind of the in-between case. It has somewhat of an atmosphere, so most of the small ones, most asteroids and most meteors are very small. So they will burn up in Mars's thin atmosphere, but it's more likely for them to reach the ground than here on Earth, but less so than the moon. But also Mars doesn't get hit by that many either because it is a smaller surface. It's a smaller planet, so it's a smaller target to be hit. And it has less gravity. So the higher the gravity, the more likely a planet is to pull in a meteor that's passing by. So it does definitely get hit, but probably not as much as us, but maybe a little more so than the moon.
We had a question, is that why the moon looks like it has more than Earth? Is it the lack of atmosphere?
That's one reason. Also, the moon, since it has no atmosphere, it doesn't have weather. So if we were hit with a crater formed on Earth, unless it was very, very large, which we do have examples of on the Earth, a lot of the smaller ones would erode away from either wind, from rain, from water, and eventually the land just gets scoured away and that crater disappears. So it's not that we don't get hit, it's just if it happened a long time ago and it wasn't very big, then it would have eroded away. And so you need a really big crater to have survived for a long time.
We have one more fun question about black holes, Amanda, is how big is the biggest black hole?
Oh, that's a good question. So there's kind of a class of black. I don't know off the top of my head what the biggest one is. However, the very famous photo that went out a few years ago, last year, I guess, of the event horizon of a black hole. That one had a mass that was about 1 billion times more massive than the sun. And it's about 1,000 times more massive than the black hole that's at the center of our own galaxy, the Milky Way. So yes, our own galaxy has a black hole. We're far from it. Don't worry, it's not a problem. But for our own galaxy, it's tiny as galactic black holes go. But some of these other ones are quite large, and their event horizons are the size of the solar system. So quite large.
Large. Well, thank you so much. We can say goodbye to the moon and close off on our YouTube live stream and say goodbye to those watching there. Thank you, everybody, so much, especially for bringing all of your questions, and especially